And tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
All right, what's up, everybody?
Well done! Well done!
Here we go. Stream. Bum ba dum boom. Nice. All up and running. GM, good morning, Jaden. What's up, dude? Good morning, dude. Yeah, today is Wednesday. Yes, today's Wednesday. It was the third day of me teaching this week at UCLA. I also had to give out an exam today. And I didn't think it was too bad. We'll see. Had like 180 students take it. What I'm kind of sad at is there's at least 5, maybe 10 students who somehow didn't realize the exam was today. So they just missed it, which I'm like, well, I mean, it's during class. You should be coming to class, right? Like, you knew we had class today. Why didn't you come to class? And then also, yeah, I don't know. Like, they're messaging me like after the exam. So I don't know, Sensation. If I was a mean professor or like any other professor at UCLA, you would usually just get a straight 0 for that. Like if you forget to show up to an exam, they just give you a 0. The issue is that
medical students,
they're pre-meds. They want to go to medical school. Yeah, they want to go to medical school. But
strange concept, pre-med.
Yeah, well, they take classes that are like getting them prepared for medical school. I think that's how that works.
I mean, your entire college system is strange. I mean, it's like,
yeah,
for us, you have to take your A-levels to get to college. For you, it's just like, what, you've passed high school, all right, fuck it. You know what I mean?
Yeah, well, we have this idea that everyone should go to college, which I think had good intentions at the beginning for things, because yes, if you want to look at like correlation between like income and anything else, like the strongest correlation there is, did you go to college? I'm sure I can find a website with it. The problem is this kind of like told everyone that like you're a failure if you don't go to college, which is wrong, you know. And so you have some people going to college that really do not have any desire to go to college, nor do they really need to go to college, because they could go to like trade school or something, right? Or, you know, we still need welders and plumbers and, you know, but yeah, education and income, I can guarantee there's like a massive trend to it. Yeah. There you go. Yeah, you want to see this? Yeah, here we go. Well, don't download this file. Or I guess this was on ResearchGate. Yeah, GDP. Like, they've done so much data on this. But, here we go. So, like, percentage with high school degree or less versus percent with bachelor's degree or higher. And then, like, what your income is. So, in the $200,000 mark, that's a lot of money. That's a nice amount of money to make. Almost 80% of those people have gone to college. And only 10% of people have just graduated high school. So, yeah, I guess the cutoff here, the average, which, this is funny. Do you see how this intersection here, Sensation, between like, where the percentages are the same, is right at 60,000. That's what is supposed to be like middle class. $60,000 like for a single person used to be, I would say, like a decent amount of money for you to live, not a super big amount of money for you to probably like support a family, but at least you can live off of 60 grand. The issue is that
for us, middle class always meant median income.
Sure. So what's the median? What's the median income in the UK?
37, possibly.
Okay. 37,000
I can't
quid.
remember.
No, it is.
Oh,
Okay,
yeah,
it says
yeah, there you go.
37,000 quid. Which what did it say? Let me get what this is in US dollars. I'm curious.
45.
Yeah, 50,000 apparently now. Oh wow, the poor pound. Pound has been going down, I guess. Y'all not having the best time. The pound has been taking a pounding. Yeah. So again, yeah, 50 grand. That's doable in the U.S. depending where you live. This is the issue: is that 50 grand in Los Angeles will not get you much of anything, to be honest. So, anyways, I think the tangent I was going down here is that, so yeah, because of this graph, in the U.S. we say, go to college, you'll make more money. And then we tell everyone you have to go to college. And this started, I guess, loosening the type of, as you said, in the UK, you have to take like O levels and A levels or whatnot. Like there's a series of like tests to make sure that you're A, like ready for college, or like B, like you actually want to go to college. Whereas in the US, we just say, hey, just go and just figure it out.
Although, interestingly enough, the A-levels might even be a hold of a much older system. When I was growing up, university was free.
Yeah.
It still is in Scotland, but it's not in England.
Yeah, university's definitely not free here. University's a moneymaker here. That's another, like, whole sector to this, why, like, college has kind of become a scam in some ways, because they're just trying to funnel people in to just pay for, like, basket weaving fucking degrees. So wrong. Like, no.
See, there's the major issue I have with the US. Generally the only one that I've got, actually. It's a pay to win system.
Yes, for sure.
And it doesn't take the individual into account. But the point is that university tuition fees are way too fucking high. Like, stupid money.
Oh, yeah. Dumb
so
expensive.
are the medical costs. The two things that people require.
Yeah.
Not as a
like basic human rights of like shelter,
it's
and like healthcare
for a person to have good education and good healthcare.
Yeah.
It is a requirement of every human being.
Yes.
And it's like, no, this is where we're going to make you pay the most.
Yes, and if you can't make it, then you're fucked.
Yeah, dead one way or the other.
Yeah, you're just screwed. I mean, so this is, on the topic of degrees, we're gonna get into doing math and science questions in a second. I like to warm up by like discussing issues that are happening, but they just put out this graph of the return on investment of university degrees by category. So I think this is lifetime like return on investment. So because again, going to college is expensive. In the U.S., if you're going out of state to a private university, you're going to pay upwards of $100,000, $150,000, sometimes even $200,000 to go to college. There are much cheaper ways to do this. You can do community college for half. You can go in-state. You can apply for scholarships or whatnot. But in general, you see here that, right, if you're going into engineering, any of the CS types things, this is interesting. Transportation, construction, and architecture. I didn't realize this was like a degree. I know you can get architecture degrees, but I would have thought mathematics and stats would be higher. But anyways, these are still positive.
I would have thought economics would have been higher.
Yeah, exactly. Yeah, physical sciences, yeah, again, not super high. Again, if you're going into like chemistry and like physics and biology, like into the pure sciences, you're not going to make as much money as, if you're going to engineers make a ton of money, depending on what they do. Economics too. Yeah, okay. But even like, I guess communication and journalism is still a net positive. That's cool.
Journalism.
Yeah, right. Even education is positive. That's also cool. Okay, so where things start to kind of go downhill is when you start getting close to like a psychology degree, which is almost like a net zero. And then where you start losing money is, yes, philosophy, religious studies. I think this also counts for, like, I don't know, like gender studies or any of these other, like, kind of wacky fucking degrees. And then visual arts and music. Not saying these things aren't important. Again, like, I'm a huge music, like, believer. I believe music and art and stuff is culturally important for society. I just think, you know, if you're going to college spending $100,000, it's not, you know, it's not the best use of your money. I think and this kind of screws things up, because then the only people that can afford to, like, produce art, produce music, and, like, culturally relevant things are rich people. So yeah.
With things like art and music, we have, this is where our system slightly diverges, but we have community colleges, or what you would call community colleges, but they tend almost exclusively never to serve higher education, just further education. Sure.
It's just like you're getting a little bit more advanced in it, but we're not trying to give you a degree in it.
Yeah.
Kind of like conservatory? Like a conservatory almost?
No, because
conservatory here.
Else as well.
This gives, conservatories, I think, give, like, degrees. Like, you can get, like, MFAs, I think. Masters in Fine Arts, I think is what it's called. Anyways. I digress. College is useful. You definitely should go if you're interested in any, you know, sort of higher education, math, science, what have it. I guess even, if you want to do, like, journalism, it is still a net positive. But don't feel like you're forced to go, and then if you don't go, you're going to be a loser. Like, that's wrong. It's not for everyone.
And if you take journalism, right, don't dye your hair green. Just put the suit on and be happy with it.
Sensation. It's like, I can't trust these
gaming journalists.
Gaming journalists. Yeah, Gamergate. Yeah.
I fucking hate white people kind of stuff. This is like,
I know.
I don't. Racist bastards, shut the fuck up.
Well, do you see, like, Trump's now doing this reverse racism where he's calling out South Africa for, like, a white genocide? I'm like, what?
That's not new.
Yeah, that's some ridiculous stuff going on. I don't know. The world is nuts. It's crazy. But okay.
Black South Africans have been killing white South African farmers for like 30 years at this point, so that's not a new thing.
Only thing I know about South Africa is District 13. So it's a great film. But
Great movie. We still need a sequel. Hurry up.
Yes. There's a lot of funny stories about that. I think there is a sequel planned for District 13. I think there is. I think there really is. There's a District 13 one coming out. That movie came about because they were trying to produce a Halo movie, and then they cut it, but then they had all the props built. They had everything already set. So whatever, I think Blomkamp was his name. He just came in and just, like, said, hey, I'll just repurpose all the props and everything here to make, like, this super low budget film called District 13. And it's fucking great. Great film. Super cool. Okay. Some quick announcements before we start getting into the homework questions and whatnot. So there is... Oh, that's a sensation cam. One sec. I gotta put you down, and then I gotta do this. There we go. Okay, one second. Let me... there's always something.
Would you like fries with that? Yes, give me fries.
Yeah, put the fries in the bag, dog. Okay, so we still have the Wibli challenge going on today, and I think it's for the next 2 weeks. I think we're ending it. Let me see. Did I put when it's ending? Oh, 3 weeks. Okay, so this is the first official week that the challenge has been open, but it's very easy. So again, if you want to win some gift cards, all you gotta do is join our Discord, and then go to the announcements page here, and there's this quick little survey you fill out, and then you follow this guide, and so this guide will kind of like tell you what to do. It's very easy. You just watch like a little video, fill out a survey, and then go through this geometry course he built. It takes like 15-20 minutes. This is an example of what the course looks like. So this is, for instance, this is the Wibli course, and it's cool. It's basically learning math through what I call like nodes or like knowledge trees and stuff. So for instance, if you start with like geometry, you can be like, oh, geometry is broken up into these things like elements, shapes, measurements, relationships, transformations. So I can be like, all right, cool. Let me see like geometric elements. And if you click on that and you hit set, Now you can learn about the different geometric elements, which is like a point, a line, an angle, and a curve. Oh, well, let's look at an angle. What can I learn about an angle? And it'll be like, here's like a description of it, some pictures and stuff. And if you hit set here, now we explore the angle node. And then there's, angle units, angle relationships, angle types. It's very cool. I like, look, angle relationships. It'll have all these. All right, so this is like a bug. So anyways, that's our friend Nick. He's sponsoring some gift card prizes. So if you haven't yet, join our Discord. You can use it going to that www.actualdiscord.com/submit. There's a link to our Discord there as well. And just fill it out, and you'll be entered to win some prizes. Yeah. Hella fun. It is free. It's all free. Yes, exactly. Yeah. Pegres Oreo. Yeah, it's totally free. It's a friend of ours who's developing geometry. Geometry is a pretty tricky class to learn. I call it like the ugly stepsister of math because I don't know, it kind of like doesn't really, it stands out from all the other math that you learn at least in high school and middle school, because now you're doing shapes and like stuff. It's like the arts and crafts of math. But he's made kind of a online interactive website tool to try to teach it better, and he just wants some feedback on it. So if you want to learn some stuff and get entered to win some prizes, please just join our Discord. It's in the announcements there. I'll make more announcements in the next week when we stream to like really get people to do it. It's like the special bus of math. Yeah. Did it update because I feel like the description UI changed? Maybe it did. What did what update? The guide update? Maybe. I know there were some errors when he first released it, but okay. I think that's everything so far. Let's start off the stream, help you guys out with some math and science questions, and get to it. All right. Welcome everyone to Office Hours. My name is Dr. Gold, Sex Education. Stream helps you math, homework, science, homework. All sorts of fun stuff. Jaden, what's up, dude? You got some here, do you want to come up and speak on the stage? You said you got to go soon, so I'll allow you to like kind of skip the line a little bit. What's up, Jaden?
So I sent you the
you sent me
questions.
send me some stuff. Okay, let's see what you need help with in math. Anybody else watching on the stream, you can submit your questions using that link down below. I updated it so it now has SSL, and so it shouldn't say that this website's a virus.
not this, another one.
Not this one. He says not this one. Okay, not this one. Okay, let's see. Boom, 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 boom. Oh, now it's condensed. Oh, Shantrix. Maybe that's because my browser looks different. I don't know. Okay, what's up?
This one I still do not understand.
Okay, yeah, this is called a histogram, is what this is. Okay. So, it says the speed of 100 vehicles on a busy highway were captured and tabulated below. Okay. So, here's like all the different speeds. You see like 40 to 60, 60 to 75, 75 to 80, 80 to 90, and so forth, yeah? Do you see
what?
that? Do you see? Okay. Here, the table, yes? Do you see this? And then do you see this is like the number of vehicles? So what this is saying is that in our survey, 18 vehicles went between 40 and 60 miles an hour.
Yeah.
Like that was their speed. Okay. So then this is 21 vehicles went between 60 and 75. 14 went between 75 and 80. 35 went between 80 and 90. They're not the same. Damn, Jeff. Yeah, that is rip, dude. Yeah. And then 12 went between 90 and 100. Okay.
Yeah.
And then here's what it says. It wants us to figure out a frequency density for each of the class intervals above. Okay.
What is frequency density?
Density is like how compact.
Frequency.
Like what?
Frequency density.
Yeah, frequency density. Okay. So frequency refers to the number of cars that are in that category. That's frequency. Density is like what percentage of all the cars are in that bin. Okay. So
density is that physics?
Density is, well, it is technically a physics term, but it can also be used in math, and that's why we're using it here. Okay. So watch. Let's say we had this. Let's I'm trying to think like binary things. Okay. Let's say people had to pick whether they like hot dogs or hamburgers. Do you have hot dogs and hamburgers in Malaysia?
Yes. We have
Okay.
hot dogs, hamburgers, McDonald's, and
Oh, okay. Okay, awesome. Okay. So let's say like you surveyed 10 people, right? And you asked them which one was their favorite, like hot dogs or hamburgers, okay? So this is what we call like the category, all right? I'm going to call this the frequency, all right? Let's say, for instance, 7 people said they like... Sorry, what?
Never mind. I asking to my mom, so
Oh, okay.
continue. My mom
Okay,
asked me.
let's say 7 people like hot dogs and 3 people like hamburgers, okay? Out of the 10.
Yeah.
Okay, cool. All right. Then from this, right, we could figure out a frequency density.
Yeah.
Which is like what percentage of the people liked hot dogs, okay? And the way to calculate that is that's frequency divided by total, okay? No, Jeff, you have to
Let's
pick your
see the
favorite over the total, okay? So the frequency here,
Wait.
right, is 7. What's the total? How many total people did we ask?
7 over 9.
7 or 10, right? We asked 10 people. See how the total here was 10,
yeah,
right? Total
Yeah. Oh yeah.
equals
yeah,
10?
Yeah,
Okay.
yeah.
So this is 7 over 10, right? So that's going to give you a frequency density of 70%. Or
So-
we can also say 0.7.
Okay.
Okay? So what would the
Okay.
frequency density of the other category be?
What is good? Is it Malay? Oh, sorry, I'm getting distracted for a bit.
Okay, don't get distracted. How do I figure out this? What's the frequency density for this?
3 over 10.
Good, 3 over 10. Right? Which is equal to 0.3, okay? That's how you figure out what frequency density is. You just do the amount here divided by the total amount. Is frequency density related to the group width? Is it?
Yes.
That's fucking annoying.
Yeah.
Really? Here it's not.
But some of the. What about the? Okay.
Oh,
Why is
thank
not-
you. Okay, I'm thinking. Oh, yeah, no. Yeah, we're wrong. Okay, one sec. So, we were finding probability density, which is what I thought frequency density was. Okay. This is so
Probability?
silly. Yeah, this is I don't know. I haven't seen this before, but okay, whatever. Okay. Sorry. This is
Yeah.
probability density. Is what I want to say. Sorry. This is probability. We're going to use this later. Probability density. Thank you, St. Raz, for bringing that up, though. That explains why the widths are different. Exactly. Okay. All right. So, it turns out that frequency density is equal to the frequency here divided by the width of your category.
But how do we know where's the width?
So the width here is between 40 and 60. Okay. So what's the width? What's between 40 and 60? How much?
60 minus 40 is 32.
Yes, 60 minus 40, sure.
60 minus 40
Uh-huh.
Hold on.
and
20.
That's just less than 60.
So it says less than 60,
Yeah.
greater than 40. You can just say it's between 60 and 40. The width there is 20. Okay. So
Yeah.
if you wanted to calculate, for instance, frequency density. Okay.
Yeah.
For this one, it would be equal to 18 divided by 20. Okay. So it's this number divided by the width here.
yeah.
Okay. Here, let me just like move this because it's so ugly. You would call it relative frequency? Thanks. Yeah. Relative frequency is a percentage. Okay, so here we go. So you would have 18 divided by 20. What would this one be right here?
21 divided by 20, 14 divided by...
No. So this one's 18 over 20. This one is 21, but then what's the width between 60 and 75?
Oh, 75 minus... I need calculator. Wait.
Yeah.
75 minus... Wait, let me... 15?
15. Yeah. Yes. Okay. And then this one is going to be 14 over 5, right? Because that width is only 5. Then 35 over 10, and then 12 over 20. Mohammed, I do chemistry as well. You can ask anything, math or science. Middle school, high school, early college. I can try it.
Well, let me anchor and return again because I pop out another player to another window.
Uh-oh. He popped up another player in another window. You can't multitask while learning. Don't do it. Oh, no.
Oh no! Oh no!
It's so dark hard. He's back.
What's up, Jan LaRue? Okay. Okay, alright. Are we good? Are we good now? Yeah?
Yeah.
Okay, cool. That's the relative frequencies. Okay. Or, sorry, that's the frequency density. Okay. Now it says draw a histogram. Okay?
Mm-hmm.
So, what you're going to do with a histogram is... I think the sum of the frequencies is 100. Yeah. Yeah, okay. One sec. All right, so here we go. Histogram. So on your axis here, right? This is going to be equal to the we're gonna say like the frequency. Okay. This is gonna count the number of vehicles that are in each of these bins. Okay.
Yeah.
And then here on this axis, I'm gonna need to put what the speeds are. Okay.
How do you know where we do we put?
How do I know? Because I've been doing it for a while. Frequency is always on the y-axis. So the number of things this is always on this axis, and then your categories is always on the x-axis. That's just how it is.
Yeah.
Okay. And then I need to look to make sure we have enough. I think the bin widths are going to be different sizes, which is so annoying. But we need to go from what's up, Seth? We need to go from 40 to 110. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9. What's up, Seth?
You should have raid time in a minute.
I should have what? A raid? Oh, a raid. Oh, thank you. Thanks for the heads up. Yeah, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there it is. What's up, Obi? Thanks for the raid, Obi. Hope you're having a fantastic Wednesday night. Hey, I was alerted to your raid early from Seth. So appreciate that. Yes, I can do buffer solutions totally. Yeah, just give me a screenshot, Mohammed, of a question. If you give me a screenshot of a question of you doing asset changes and stuff, then we'll do it. Went well, good. Glad to hear that, Obi. As the widths are different, we use the frequency densities rather than the frequencies. No, that gives a fair comparison of unequal intervals. Yeah, so that's interesting. I feel like in doing this histogram DVG, I feel like this, like the width is going to be different, right? This is weird. I haven't seen like histogram
What's
the
question?
Here, I'll post it in I'll post it. 1 second. I gotta move it over.
Maybe you can speed up a little bit because
maybe I can speed up. What? Okay, 1 sec. Let's see.
you have to go to school soon.
I know.
Which one?
But if I posted it in office hours, it's in the chat, or not the chat.
Seth, can you help me?
Maybe Seth can help you. Yeah, maybe Seth can DM you later. But yeah.
For what?
For this question.
Okay.
Let me
The gram test.
see. I need this with like different with what is it? I need this with like it's not relative frequency. Sorry, it was frequency density. It's all in Norwegian. Oh well, maybe try to translate it. Yeah, no. Look what they do. They change the size of the. They change the size of the bin widths. Oh, whoa, that's crazy. Interesting. Oh. I haven't seen this before. I haven't seen it. Histograms of frequency densities? That's super weird.
Yeah, not that bad, honestly, but
Yes. Yeah, okay.
you're just trying to find the best line for your yourself.
Yeah, I just don't like that this is how they graph things, dude. It's so annoying.
You have what speeds do you have labeled right at the moment?
Oh, I don't have them labeled. So give me a second here. I see. Okay. So let's look at this the best way to learn is just to look at examples for how they do things. So they do have the width changing on my histogram. And then instead of putting frequency, they put frequency density. Okay. I guess that's a histogram.
Yeah.
Maybe
Okay.
we can figure this out while I'm going to school.
Well, here. You got the frequency densities, okay? The only thing you got to do here is you now have to like plot like how high they go up and how wide they are here.
Okay, I'll try that by myself later.
Okay, try it by
Next
yourself. All right.
Oh, well,
Oh.
next question.
What do you mean next question? You have to go to school, right?
Oh, that's it. Yeah, I'll try it by myself if I can.
Okay. Okay, cool.
Bye.
Okay. Bye. Okay. Yeah, it's like okay, certain topics I can't just teach in like two minutes. Like what? Can't do that. Yeah.
We could do Shantrix as Twitzen if you want.
Let's see what we got. Shantrix does have a good one. That looks like it's gonna be tough.
Not that. That's not that bad.
It's not that bad.
Compared to what I just did.
Okay.
Dave Obi.
Let's see. All right.
Because I Dave Obi is what we did a series of things for the last 4 hours.
Okay. Here we go.
Remember the lights I ended with that last time?
Yeah.
I gave him some variance problems that we went through.
Oh, that's
The
cool.
last one that
With the
last
switching
one that
lights and
rather
stuff. Yeah.
The last rather very annoying, quickly.
Okay,
Everything was
8 teams
spreadsheet.
compete in a tournament. Each pair of teams plays exactly 1 game against each other. There are no ties. If the 2 possible outcomes are equally likely, what is the probability that every team loses at least 1 game and wins at least 1 game? This is always like a 1 minus probability, right? Like, so winning at least 1 is the same thing as 1 minus the probability of losing all of them, right?
And so losing at least 1 is the same as 1 minus probability of losing.
Right. And then losing at least 1 is equal to 1 minus the probability of winning all of them. Okay.
And there are 2,048 games that are 2,048.
Each pair
No,
each pair of teams plays exactly 1 game against each other. Okay.
2,048 pairs. The last 2.
How do we do that again? Sorry, how do we do? Is that 8 choose 2?
The last 2 there, it's 1,024, but they're they've been simplified on the last 2 there.
I think total games is 8 choose 2, which I think it's 8 factorial over 2 factorial times 6 factorial. I think that's how you figure out how many total games there are.
Which is not
okay.
bad.
That's a good thing to know.
Times 7 times 6 times 5. So
I think they have this actually in the I think it's in the calculator. Yeah, and choose R. They have this. You can do this in the calculator. You can do 8 choose 2. Well, that's only 28.
because you're dividing by 2, which takes out a factor, and then you're dividing by 6, by 5, by 4, by 3, by 2, by 1. So it's 8 times 7 by 2, which is says 4 times 7 or 28.
Yeah.
Good.
56 divided by 2. Yeah.
Which
Oh,
is not bad.
here. Oh. There you go. Jeff says, I agree with this. Jeff says that like 28 games equals 2 to the 28 outcomes. I see. Because amongst the games, Seth, right? The game can either be a win or a loss. So you have like
2 to 28,
Game.
which is 20.
game, right? Game 1,
It's
game
not-
2, blah 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 blah. We have up to game 28, right? And then each one could either be a win or a loss. So there's two. So it's like it's 2 times 2 times 2 times 2. Okay, cool. So this is 28. So it's 2 to the it's 2 to the 28th.
That's what
That's
he said.
That's a big number. Dude, what is 2 to the 28th?
It's not an approximation. It's an equals.
Jesus, look how big this number is, dude. What? That's a
So it's not
that's
bad. No, it could be that and just be simplified a lot. But
yeah, it could just be simplified a lot. Yeah. So
that-
yeah, 2 to the 28th is this huge thing. Okay. Honeycomb says, luckily I have 26 more days of school. Nice. I think UCLA has 14 more days of school. Maybe 16.
It's not 2 to.
Wait, and so that's okay. What is the probability that every team loses at? So what's the probability that a team lost every game? Is it
And
possible?
and
But
they-
it's not. But it's not possible for every team to lose every game, because there has to be a winner, right? Does that make sense?
If
Not
one
if you
team-
release tigers onto the field.
Unless we release. Yeah, let's settle this in the streets, dude. Every team loses at least one game. Yeah. So the probability of losing. So let's say like team 1 loses every game. That would be equal to 1/2 to the 28th, right? And then the probably that team 1 wins every game that's 1/2 to the 28th.
which is one of
Sorry.
the 7th.
No, okay, sorry. Thank you, Jeff. Sorry. Yeah, sorry. There's 28 total games between all the teams, but there's only 7 games per team
Yeah.
because every team plays the other 7 teams. Got it.
Oh,
Okay, thank you.
Interesting thing. There's an interesting thing. 2, 4, 8, 16, 32, 64, 128, 250 sets. That's 1 over 250 sets.
Uh-huh.
It's not approximately.
But then here's kind of the weird thing is that
Approximately though.
yeah, okay. Yeah, it's actually okay, whatever. The weird thing here is that I can't have, for instance, like it's like mutually exclusive, right? I can't have team 1 lose every game, and I can't have them also win every game. And by the same token, I can't have all the way up to I can't have like team 8 lose every game and team 1 lose every game, because 8 and 1,
That's
or
fair.
just in this case, right? Team 1 and team 2 had to play each other at some point, and they both can't lose. So, oh man. So you're missing like 1.
It's tricky.
This is really tricky. This is a
We
mindfuck.
can-
I thought you said this one was easy.
There's a Twetson number if that helps.
Oh, I know 24 is up there. Jeff says, actually, that helps. Oh, yeah, wait. Oh, wait, yeah. Yes, Jeff brings up a good problem. Okay, so for instance, you can't have 2 teams lose every single game. Oh, that's very cool, Jeff. Yeah. Because Team 1 and Team 2 eventually have to play each other. So you can't have both of these statements be true. Okay? So, the only way you can have you can only have one team lose every single game. And by the same token, you can only have one team win every single game. So the chance of one team losing all 7 games, yes, is 8 over 2 to the 7th. Yes, yeah. Or 8 times 1 over 2 to the 7th. Okay, so here you go, yeah. So 1 over 2 to the 7th is the probability of Team 1 losing every game, right? But then there are 8 teams that could do this, right? Because we could also say the probability of Team 2 losing every game. So in total, there's 8 over 2 to the 7th probability of a team losing every game. And then there's also 8 over 2 to the 7th, sorry. Probability of a team winning every game. Okay. And then you double count the cases where both happen, right? So is there a case where now there needs to be a chance for someone to win all the games and someone to lose all the games. So I think we subtract like 8. There are like 8 ways. There are 8 different ways that could happen. Or there's 8 choose 2. There's 28 different ways that could happen. Okay, I think we're getting closer. Okay. So I think this is 1 minus 8 over 256 minus 8. Okay, that's 1 over 8 minus 256. This is 1 over 8 over 256. 1 minus 8 over 256. And then I believe you need to subtract the probability of there being a team that wins every single game and a team that loses every single game. And the only way for that to happen is out of like your 8 teams. You need one to win all of them, and then you need a different one to lose all of them. Because this is counting the probability that you could have a team win all the games and lose all the games, but that's not true. You can't have a team win all of them and lose all of them. So it's 256 minus 8 over 256 plus 256 minus 8 over 256. And then I think we have to add in the possibility that the same team won and lost every single game, which is plus, I think I got this. I think this is plus 1 over, I think 1 over 8 times 1 over 8 times, was this 8 over 256 times 8 over 256? I think this is the double counting, is what this is. Or it's this, or I think it's this times 8, maybe? I think it's just 1 over 8. The only thing I think is that one team losing all and another team winning all is independent. And I think that's where this comes into play, Jeff. I think I need this. So the probability of me choosing like this team and this team to both like win and lose all of them is 1/8 times 1/8. That's for me to pick the same team. And it's not independent, yeah. But then we multiply that by 8 because there's 8 ways to do that. So that's going to kill off one of them. And then it's the probability of this and this, which is this and this. Okay, I think I have it. I could be wrong. I see why what we want the answer to be in terms of like 1024 or almost 2048. I see where the 2048 comes from. Because, well, that's me 256 squared. Saint thinks it's D. Yeah, let's see. So this is 248 plus 248 over 256. Oh, wait. That's a probability greater than 1. We don't like that. Uh-oh. Oopsies. I can't add those probabilities. Huh. Selman? What is Selman? Dude, what? Okay, Shandrix. Shandrix, give me some help on this one. I think I'm close. Probability racks my brain sometimes, man. It really does. You could guess the probability of both happening. It's the product of the probabilities, which is 8 times 8 over 2 to the 14th. Let me get a hint. Okay. Show me a hint. Where's my YouTube chat not working? Oh, it's watching the wrong chat. God damn it. This thing. Shandrik's getting a hint from us. Balancing equations? Yeah, we could do. Okay. When in doubt, ChatGPT'd out. Let's see what ChatGPT says. Let's see if ChatGPT gives me some nice inspiration for this. We'll send 04 at it. Good. Yeah, look, this is cool. So it says there are 28 games in total. We need to calculate the probability that no team is undefeated or winless. First, we define events in which all its games... Yeah, there's subsets. Yeah, no two... Okay, here we go. Yeah, here it goes. Okay. So there are a total of 28 games. We got that from 8 choose 2. Each is equally likely to go away, so... we want the probability that no team wins all 7 of the games and no team wins all... Okay, good. So probability that every team has at least one win or at least one loss is 1 minus the probability that there exists an undefeated or a winless team. Right. So you want 1 minus the probability that there's a winless and 1 minus the probability that there's an undefeated. Or. Because you can't have every team be undefeated and winless. Okay. Wow, this is cool. Using like wins all 7 of games. Okay, so we need the union of count bad outcomes by inclusion. So winning all or losing all is the sum of winning all plus the sum of losing all minus the sum of losing and winning all and losing all. And then you have I can equal J. And right, two teams can't both win their mutual game. And then they can't both lose. Okay. So, if Team I wins all 7 of its games, all 7 of its games, it fixes those 7 so that the remaining games it plays, there's 21 outcomes. Oh, okay. So now instead of, okay. And now instead of 8 choose 2, it's 7 choose 2. Oh, okay. Where's the 16 coming from here? To the 21 because 7 games are fixed as losses or wins. Times 2 to include both the 7 minus win runs and the 7 win runs and the 7 loss runs. Okay, cool. And then 8 because there are 8 teams that could do it. Oh, thank you. Thank you, Saint. Okay. I see. So, yeah, 2 times 2 to the 21 times 8. Okay. And then, okay, then we need the probability of this, which is minus the sum of them winning and losing all their games. Winning all their games and losing all their games, but you can't have the same team do that. So here must beat all the 7, and J must lose all 7. And these specifications overlap in exactly 1 game. Okay. So the total they fix is 13. I see. And then there's 8 times 7. Because there are 8. The bad probability is 1. That's pretty cool. Very lengthy. I mean, very. Let's see what the official Waterloo submissions were. Okay, so this was Jesus Christ. What? This whole thing was how they solved it? Oh god. Yeah, no. Answer choice is D though. Okay, cool. Cool question. You can't have both at the same time, so it's irrelevant. Yeah. Yeah. I agree. Yeah, probability is very tricky. You have to like think about, especially in this case of things being independent and mutually exclusive. It can really get really mess with your mind trying to figure out like what's going on. GG. Yeah. Good job to Saint. Saint, you did get it. You just need to pick the probability of one team winning all the games. Yeah, but as we saw here, you also needed to include you also needed one team losing all the games. And then you needed to subtract by the probability that one team won all of them and one team lost all of them, and it can't be the same team. That's the that's this. So wait one second. That's the overlap we were talking about. Yeah. This would have been just the probability of one team winning all their games. So this was like win all. This is like lose all. And then you had to subtract win all and lose all. Because this is not possible. And you're double counting here, right? This is like the probability of, you know, A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And then this was especially true because you couldn't have the same, you couldn't have Team I and Team J be the same team and both win all and lose all. Yeah. It's like layers of like what's possible and what's not possible. Yeah, because you double counted the outcomes where you had both a team winning all 7 and another team losing all 7. Yeah, exactly. When you had this. And then you also have to remove the double counting of it being. So first of all, you can't have like team 1 and team 3 win all, lose all. And then you can't have like team 3 and team 3 win all and lose all. Yeah. So that's why this then got a little bit more complicated because you had to include I mean, this was kind of it. This was it. I like how ChatGPT broke it down. I feel like their explanation was easier. Minus 2AB. It was a little bit more complicated than just 2AB, though. I mean, close OB. Yeah, because it's like double counting within double counting, right? Right. Right. Yeah, so the number of games where someone won every single one would be that was Team I winning all 7 of his, right? So that's why it was that fixes 7 of the games. So then there's 21 games left to choose 2 outcomes. And then let me remember if Saint had it right. Inclusion. Yeah, what's up, Zach? Give a shout out to Zach. It's kind of like A plus B minus A times B for certain definitions of plus minus. And yeah. Yeah, it's confusing. Okay, but it's cool. It's a cool question. These things, they're fun. They're fun little mind puzzles. If you do enough of these, you can kind of get into a mindset of how to solve probability questions, and things start making more sense, which is great. Okay, but good question anyways. Let's see where Equity is. Is Equity online? He submitted a good question here. Something with like human cannonballs. Pourquoi? Okay. That question is the sort of stuff they ask in quant interviews, so I've prepped it. Oh wow. Yeah, yeah, that's good for like economics and stuff for sure. Yeah. All right, let's see. The range of a human cannonball act at a circus can be modeled by this. Oh, this is the range equation. I always tell students in my physics classes, like, don't memorize this. Because the range equation only applies for figuring out how far something will travel. So if this is like the range, R, it only applies when you have an object that begins at a height and then ends at the same height. But it is cool. So like if this is V and then this is equal to theta, you can figure out that R in this case is equal to V squared over G sine of 2 theta. What's up, Equity? Yeah, let's do your question. So yeah, that's what the range equation shows. It shows like how far this thing will travel if it's shot with a certain velocity, a certain angle, and then gravity is gravity. Okay. So it says the target net is placed 20 meters away. The human cannonball is launched at 15 meters per second. Determine the angle or angles at which the cannon could be aimed to hit the target. Yeah. So, I mean, this is just solving this. If we're not having any other questions, I'll show you how to derive this without memorizing it, because it's kind of garbo. Because they will never give this to you on an equation sheet. You'll never get the range equation. They usually give you the kinematics equations and you have to solve for it. I will show, yeah, exact Saint, I'll show it to you. It's really cool, actually. All right, so range here is 20 is equal to V squared, so that's equal to 15 squared over 9.8, and then it's the sine of 2 theta, okay? So, I mean, you can just move all this stuff over. So, this is just, here, and let's, it comes from the double angle formula. Fem is right, yeah. So, what is this? 20 times 9.8 over 15 squared is equal to the sine of 2 theta. And then, if we want to do that in a calculator, because I need to do 20 times 9.8. 20 times 9.8 divided by 15 squared is 225. We get 0.871. So 0.871 is equal to the sine of 2 theta. Okay. So then what I do to like free the theta here is I'm going to take the arc sine of both sides. Okay. And so this is going to go away. And if I take the arc sine, that's going to give me 60.59 degrees is equal to 2 theta. Now here's the key thing. Yeah, I'll show you. Yeah, the parabol. I will show it to you, Obi and Fem. Yeah, it's super cool. Free the theta. Yeah, so we freed the theta here. The key thing here is that when you do arc sine, you technically have 2 different solutions, but the calculator will only give you one of them. So in this case, right, we took the sine of like 0.87, the arc sine of 0.87. So that means that I'm going to draw the angle approximately. That means that your opposite over your hypotenuse, right? This is 0.871, and then this is equal to 1. And then this is theta, okay? So this is where, for instance, sine of theta equaled 0.871 over 1. However, there is technically another place that this happens, and that's going to be over here, where this is equal to theta. And you'll also get 0.871 and then 1. And so your calculator will only, when you do arc sine, how the domain and range stuff for arc sine is defined, it'll only give you values here. So you have to do this one as well. And so that one is going to be 180 degrees minus theta. So when doing our solution here, I'm going to say, okay, 60.59 is equal to 2 theta, or 180 minus 60.59 is equal to 2 theta. Okay? So now when I solve this, right, by like divide by 2, that's going to get me 30.3 degrees, basically. And in this case, that's going to get me, what is it? 119.4. Right, yeah. 119.4 divided by 2 is 59.7. Yeah, cool. Oh, this is the cool thing. These two angles have to add up to 90. You could add multiples of 360. You could to here. You could add multiples of 360, but then you start getting angles that don't make any sense. Did you see the? Yeah. Oh yeah. Good luck on your statistics exam, Devil. Let us know if you have any questions about it. But okay, equity. So that's why there are two angles that this can happen. It can happen at 30.3 or 59.7. It turns out when you do like the range equation, why do they have to add up to 90? So kind of cool here. So let's say that this was the angle I got right from doing arc sine. Let's say that angle. Let me come up with a different color for it. Let me say that this angle was equal to x. Okay. So we have x is equal to 2 theta, or 180 minus x is equal to 2 theta. Okay. Let's call this like theta 1 and like theta 2. Okay. Like this is us solving for an angle, doing it the first way, and this is us solving it the other way. I will do it tidal wave. I'll 100% do it. I'm going to do it next. Okay, so watch what happens here, equity. So first of all, if I divide both sides by 2 here, right? I get x over 2 equals theta 1. And then I get 90 minus x over 2 equals theta 2. And then look what happens if I add theta 1 plus theta 2. That gets me x over 2 plus 90 minus x over 2. These cancel. And you just get that the angles have to add up to 90 degrees. Wow. So, pretty cool. One second, let me find the range. Ooh, you can't understand hypothesis tests? Yo, send a screenshot. I'll help you with hypothesis testing, Devil. I love that stuff. There's like a cool graph of like range equation, different angles. Yeah, this is the picture I want. This picture is really cool. Okay. I woke up today sick, feeling better. Oh, I'm glad you're feeling better, dude. One sec. Why does this keep messing up? Next time someone asks me what some kind of math is good for, I'll tell them it's so that I can be the president of Romania someday. That's cool. But yeah, so here, for instance, look, if you shoot something at a 15-degree angle, you only get the range being 5. And if you shoot it at a 75-degree angle, you also get it being equal to 5. So this is like kind of a cool thing showing how like, and see how those angles add up to 90? You remember seeing this today? Have you seen this today? Really? Okay. Okay, but let's explain where this range equation comes from, because it's actually pretty cool. So, let's say, for instance... Oh, the president of Romania. That's cool that he's a math guy. Okay. Alright, let's say something is being shot at an initial velocity v0, and then at an angle theta, okay? This means, right, that it's going to have two components. We're going to have, like, v0x, which is equal to v0 cosine theta. And then it's also going to have a component of v0y. which is equal to V naught sine theta. He got a perfect score on international math. Is that international math Olympiads? The range equation is okay too. Yeah, it's not as cool. Hey, it's your bestie. What's up, Marty? Throwing pails and putting cubes, yeah, and spherical cows. Okay. So if I have an object here and it's being thrown, right? A certain amount of distance, okay? It's going to end up falling some distance here. Here, let's draw this out. Okay. Now, the distance that thing travels from here to here, which we're going to call range, which is equal to delta x, that's equal to the velocity in the x direction times the amount of time that it spends in the air. Okay? This comes from our kinematics equation of x is equal to x naught plus v naught t plus 1/2. Yeah, no, I definitely do pre-calc and calc. Yeah, submit a screenshot. There's a website down there. If you submit to that website, submit a screenshot of what you need help with and I'll go over it. Okay, so in the x direction, you have initial velocity, but you don't have any acceleration because there's no forces acting on the ball in the x direction when it flies this way. What does v naught mean? That means the initial velocity. The initial velocity that the ball is shot with, right? This is the initial velocity it's shot with. And so that initial velocity, if it's shot at an angle, has a y component to it and an x component to it. And then the distance it'll travel in the x direction is just equal to the velocity in the x direction times the time. So that's equal to v naught cosine theta times t. All right. Now I need to think about what happens to the ball in the y direction, okay? Because as the ball goes from here, from the left to the right to where it splats, it also goes up, right? And then it comes down, okay? So we can think about things in the y direction as well. So we can say, okay, in the y direction, so this was in, so this is x. In the y direction, you have y is equal to y naught plus v naught yt plus 1/2 ay t squared. The initial and the final position are both 0 because it starts at 0 and it ends at 0. Well, yeah, it starts at 0 here on the ground, goes up, and then it ends at 0 down on the ground here. So this is 0. So I say 0 is equal to v naught y. So that's going to be v naught sine theta times t. And then plus 1/2 at squared. So that's going to be minus 1/2 g t squared. Do I memorize these equations? I do. Well, I've been teaching this for like 20 years, so I know these equations. You are going to be given this on any sort of like exam. They will give you this usually. I'm just showing how you can get this cute like range equation that comes out. This range equation can be re-derived from just knowing this simple equation, just knowing this one. Okay, so if I were to solve now for the time it takes, because let's remember, if I want to figure out how far it travels in x, all I need is the time, and the time it spends traveling this way when it's in the air is the same time it travels this way when it's in the air. So I look 20s. Oh, thank you. I'm middle 30s at this point, but I appreciate the compliment. What do they call it? The Riz. Okay. If I solve for t here, I get 1/2 gt squared is equal to v naught sine theta times t. And so what I'm going to do is I'm just going to divide both sides by t, which I know math people get mad at. They're like, don't do that. But all that does is remove the solution where time equals 0. And time equals 0 is called the trivial solution. Like, I don't really care about, yes, I know when it's starting here and ending here, yes, that could be that no time has elapsed. I only care about the non... I could factor by t, yes. Just know, if you're dividing both sides by a variable, you're technically getting rid of the chance that that variable could be 0. But t equals 0 is nonsense to me, because then my range would be 0. As long as I state it, I'm okay. Cool. All right, thank you. I appreciate, yeah. I've gotten the blessing of the math gods. We tend to, like, do things in physics that don't make math people happy. They're just like you're not supposed to do that.
That's
Oh
true.
no! Oh no!
We're not as bad as engineering, bro.
No, no.
Engineering starts saying that, like, pi is equal to 3. Like, you stop with that. This is why you'll never be the president of Romania. Slight side eye if you don't state it. Yeah. Okay, all right, I'm going to state it. I'm going to state it for you guys. So, t does not equal 0. Okay, watch what happens. So, now we've got this. And so now I can solve for t. And I can be like, okay, so t is equal to v naught sine theta. And then I'm going to move the 2 over and divide by g. So that's going to be 2 over g v naught sine theta. Now look what happens. If I plug this in for t here to get my range, right? Which was the amount of distance it travels this way. I'm going to get that r is equal to v naught cosine theta times 2 v naught sine theta all over g. Okay? So the v naughts I can combine. That's going to be v naught squared. And then I have 2 cosine theta sine theta all over g. And then this is a really cool identity. This is why you take pre-calc. I know everyone fucking hates pre-calc, but this is why pre-calc is cool. Because
Pre-calc. It does.
it just helps you out, man. Like, this is the identity we need. One second, I'll pull it in. And this is equity. You've been learning this, right? He's been doing a bunch of pre-calc stuff. But look at this. Look at this. The double angle identity. I need this one. Here, we'll just get rid of this. So, 2 sine theta cosine theta, which is this, is equal to sine of 2 theta. And so this is why the range then comes out to be v naught squared sine 2 theta all over g, which is the same thing that you were given in your equation here. So it's pretty cool. That's where it comes from.
So that's probably well, not same set.
One sec. Zach says, if you're willing at some point, I would like to see a problem that involves tension. I find, yes, yeah, tension is great. One sec, let me pull that up. I will do that one later. That's a good one, Zach. You said question 21? Oh, God, yeah.
I did see if I... No, I don't have that paper anymore. You need an easier one than that?
No, one sec. We'll do this one in a second. Let me check the chat for things. Also, Equity technically has another question I need to do. But
Yes, he does.
let me see the chat real quick. Tidal Wave says, I know you were doing a problem, but I'm interested to see a derivation for the horizontal range if something is shot off a cliff at an angle theta. Yeah, so that changes. So, in this case, right, when we were solving... It's the same thing, by the way. You're still going to use this. You're still going to solve for time. But now, y and y naught are not the same. Okay? So now this is 0, but this is not 0. So what happens is you get, let's say your height is h. Let's say y is your initial height. You get h is equal to v naught yt minus 1/2 gt squared, which is then h is equal to v naught sine theta minus t minus 1/2 gt squared. So now this is not an easy thing to solve for t. Here it was, because I literally just cancel t on both sides because I don't have an extra constant like hanging around, and then you can get a nice expression for what t is. In this case, you'd have to do the quadratic equation. and this looks really ugly. But you can still solve for it. It's still possible. You would just hopefully be given some numbers here to solve for t, and then you just plug t into here. And because all this is really doing, right, is you're just modeling a parabola like this. And for instance, if you're starting somewhere higher and then you're ending somewhere lower, you're gonna get two different times. This is like the negative time, and then this is like the positive time. You get like a time that like in the past when it was at the ground, and then you get this, the positive time where it actually hits the ground. But you're having it start here. Yeah. So that's where it come from. The derivation, this is not as nice and clean. It's kind of ugly. Okay, let's see. Do we have any? I don't see any web help. Let me make sure the web help screenshots is working for people. So if I go to www.actualdiscord/submit and I say here test username.
Featuring moment.
And then let me say I like just put this question in here and I hit upload. Okay, and does that come in? And it does. Very cool. Yeah, because then what happens is we end up getting the screenshot here. So yeah, if you were wondering and you wanna ask questions and get help, you can always submit screenshots using that website.
We're doing the other from Metro.
Yeah, let's do the other equity question, and then I want to do Zach's question with tension, because that is an interesting one. Tension does tend to create problems.
A rich.
What is the curvature of a flat Earth? Is it 8 inches per mile? Is that really what it is? Okay, here we go. The piston in a lawnmower moves up and down 30 times in 1 second. Okay, so right away, before I even read any more here, I'm going to be like, okay, cool. Frequency is equal to 30 hertz. Because this is equal to 30 revolutions in 1 second. Or you could say like 30 cycles in 1 second. Its total travel from the top position to the bottom position is 10 meters. Okay. So that tells me the amplitude is equal to 5 centimeters. Right? Because if you have something moving from here to here and that distance is 10, then the halfway distance is 5. Oh, that's cool. They actually did it. Oh, wow, that's cool. 8 inches per mile.
The vertical
is that
position y in centimeters versus time t inside density model using a sinusoidal function.
Good. Yeah. Now here's the question: Where does it start? Oh, they don't tell us this. Okay, so this is cool. So amplitude is 5, frequency is 30, and they just want us to come up with a sinusoidal. So that's just this, right? Y is equal to A sine.
What are you doing exactly?
Oh, sorry. Yeah, sorry.
Oh,
There we
there, but
Yeah, this is what I meant to say. Sorry. So frequency is 30 hertz, right? 30 cycles per second. Because something moves from a highest point of 10, right? Well, if this distance is 10, then the amplitude, which is the halfway distance, is 5. Yeah, okay, cool. Yeah, so omega t plus phi. So this is the equation. Oh, and then it's also like plus like c, which is like the offset.
let's plug stuff in them.
Okay. So he's wondering how to get this. So omega is equal to 2 pi f, which is also equal to 2 pi over the period. Which, yeah, sometimes instead of saying omega t, they'll say kx. So that depends if your wave is oscillating with position or if your wave is oscillating in time. Because waves have like 2 different dimensions that they do things in. Okay, so yeah, this is all you have to do to get this, man. It's just omega is equal to 2 pi. My brother in Christ, you have a PhD. Yes, so this is 2 pi times 30. So omega is equal to 60 pi. And then the amplitude is 5. So you have y is equal to 5 sine of 60 pi t. And then here's the cool thing. Is like technically there's a phase difference you could do. And then plus c. Can you write the equation like that? Yeah, okay. So
You're gonna write an equation and model it.
yeah. Yes. Oh, that's cool about the Fourier thing. Okay, so I hate when teachers do this. Okay, first of all, this is y as a function of x. Which is, right? But here we're talking about the amplitude of something as a function of t. So that should be y as a function of t. How this changes, right? This is kind of like a physics semantics thing, but this is for y as a function of x, which is like what's the amplitude of my graph? What's the amplitude of my wave at a position x? It really should be this. Y is equal to a. Why are they saying f of what? What? Dude, excuse me? Or f is sine or cosine? Dude, what? Why? Why are they doing this? God damn it! Why do people try to teach it this way? This is so confusing.
That is one big pile of shit.
That's what
Big pile
Obi's
of
trying
shit,
to
dude.
Any differences?
Oh, that order is nuts, dude. What? Yeah, bro, tell your teacher to, like, lay off the fucking Vicodin, dude. What the hell?
Obi, you might want to add that to your list of DE problems for later.
Okay. All right.
See if we can get a better way to teach that.
Yeah, bro, what the hell? This is so bad. Okay.
Oh,
In this case, it's not k, it's omega. And then it's t minus phi. And then it's plus c. Let f equal sine and cosine. Thanks, Seabass. I did get your problem, Seabass. Ooh, nice. Seabass did submit one. Nice, good job, Seabass.
Actually, put an example.
Yeah, okay. I mean, that's fine. I mean, we basically said the same thing here, dude. Okay. So, this right here, this is the amplitude, right? This is the phase shift, but the phase shift can be whatever. That depends on whether it's starting at 0 or ending at 0. And then this right here is equal to omega or k. When it's k, it's equal to 2 pi over the period. Or it's really over the wavelength. It's 2 pi over lambda is really what it is. And if it's omega, it's equal to 2 pi over the period. Or this is also equal to 2 pi times the frequency. Oh, phi over omega. Yeah, exactly. Sorry, you're right. This is phi over omega because this thing is then omega or k. And then this is the offset. Yes. I've only seen period as P. No, we use this for period. We use big T. For sure. Really? Devil, you never seen it that way? Yeah, no. We primarily... Yeah, these different variables are confusing me. Yeah, okay.
TD being the phase shift.
Yeah. Whatever. Yeah, because he's seeing all this stuff, and he's like, what's going on here? Like, lambda is technically a wavelength. And then this is a period. But they mean the same thing. It's just in, like, different instances. So, let's say, for instance, you have a standing wave. Right? So... Have you ever seen this? Where, like, you have, like, a person here. And they're, like, holding a jump rope and they're, like, doing this. Well, first of all, like, if you were to send, like, a single pulse. Right? This pulse would move this way. And then it would flip. And then it would come back this way. Have you ever seen that? Like, if you have, like, a rope attached to a certain point. And you start moving this thing up and down. You can send, like, pulses of waves. Then they hit here, they reflect, and then they move back. It then turns out, so if you send the pulses at the same rate they're coming back, it'll look like the rope's not moving at all, okay? And so what you end up getting, this is electronics, yes. you end up getting this, which is called, here, let's make it like a little bit better. You get this, which is called a standing wave. Okay. Which is looking at the amplitude of something as a function of its position. In this case, okay, the distance from here to here is called a wavelength. Okay? And that's the distance in space that it takes for a peak to appear and then for another peak to appear. Okay. Now, let's say, again, you're sending the pulses and whatnot, and you're looking at, so this is freezing time. Because it turns out, technically, you're also going to see the opposite thing happen at different times. I thought the standing wave was what the crowd did at a sports event. Okay. So that's freezing time. But, for instance, you could have also... Let's just copy this down here. You could have also, like, placed, like, a sensor here. Like, let's say you place, like, a sensor here. At a certain position, right? A certain position X. And you look at what's happening to the amplitude there. You would see it oscillating back and forth between up and down. In that case, you're freezing the position. And now you would see this graph as a function of time. And actually, this would keep going on forever, right? This would like just keep going on. In this case, the distance between two peaks, that's called a period. Exactly. No. Yeah, you're thinking of a jump rope? Yeah. But okay. So whether we're calling it period or we're calling it lambda, for your sake of your questions, it's the distance or the time between it oscillating one complete cycle. So if this thing does 30 cycles in 1 second, then the flip of that would be 1 over 30 seconds for a cycle. And this right here, this is your period. And then K or omega, whatever, or your teacher calls it K, is equal to 2 pi divided by the period. I don't like this because K is usually reserved for wave number, which is with position. And what you're really doing is you're doing omega, which is reserved for stuff in terms of time. So K is pi over 15? Yes. Yes, it is. That's it. Why argue over sine and cosine? Isn't this also...
That's dope.
Fucking Zach, dude. Zach's like, it's all just e to the I kx plus omega t. Yes, so it's all Euler's identity. Yeah, so at the end of the day, really what you have is you have f of x and t, which he's right. It's equal to like is it sine kx plus omega t? I think this is what we usually say, right? And then and I think there is plus phi. I think there is plus this. Yeah. But then if it's in two different directions, then you get the spiral. Right? Or let me draw this right. Okay. I don't mean to confuse you, Equity, and I want to help out was it Sebastian who asked a question, but it is cool stuff eventually. There is no phase shift. There's no phase shift because they didn't tell you. They didn't tell you where it started. My teachers had to skip over this due to time, so thanks for helping. My teacher calls it K2. It comes from the general, yes. Ah, okay. Yeah. Okay, here. Let me get your continuity question. Yes. Wait, what's up, Descendant Fonts? Descendant Fonts showed us how pi was not equal to 22/7 the other day. That was pretty cool. Okay. Anyways, I hope that makes sense, Equity. Yes, that is the equation. Correct. And then the reason why they say that there could be more than one equation, Equity, is because you could put a phase shift in there because they didn't tell you where it starts. And then just graph the regular one. Imaginary numbers aren't real. They can't hurt me. Okay. Let's see this. Sebastian, thanks for submitting your question, by the way. I'm glad you figured it out. Okay, it says find the value of a such that the limit as x approaches -1 of f of x exists. Okay. So in order for a limit to exist, right? So if the limit as x approaches a of f of x exists, then the limit as x approaches a from the right equals the limit as x approaches a from the left, which does it also equal f of a? Is this last part necessarily true?
Sometimes.
Sometimes.
But disunities can certain disunities can happen. But some of them to not, on the other hand. Not needed. So then
Oh wait, one sec. Equity, you got this wrong. One sec. You didn't divide by t. Sorry, one sec. One sec. Let me help Equity 1 second. 1 second. Sorry. Period here, Equity, was equal to 2 pi over 1/30, which is equal to, flipping this on the top, is going to be 60 pi. Sorry, let me do this right for you, sorry. K equals 2 pi over t, which is equal to 2 pi over, and then t was 1/30. So that's why it becomes 60 pi. Do you see that? Period is 1/30. And then if you're dividing by 1/30, you're multiplying by 30. That's why it's 60 pi. Okay. All right. Not needed, only for continuity, not for the limit to exist. Okay, cool. Thanks, Endar. Yeah. And I think you said that as well. Yeah, thanks. Okay, so this is not needed. This is only for continuity. You're welcome, dude. Okay. So, cool. So the limit as x approaches -1 from the right, that's when x is greater than -1. Okay, so that's equal to ax minus 1. Well, here, sorry, let me move this. I need to move this on I hate when it catches it. 1 sec, here we go. Limits are not that scary. I don't think they're that bad. Okay. Here's what I want to say. Okay. So, what we're going to show is that the limit as x approaches a from the right of f of x is equal to the limit as x approaches a from the left of f of x. Okay? The limit as x approaches a from the right of f of x, that's this one. That's equal to the limit as x approaches a of ax minus 1.
But we know it. We don't care about a though. We care about -1.
Oh, sorry. Thank you. That's what I meant.
Well,
That's what I meant. Yeah, that's what I meant. Sorry. Yeah. Sorry, that's what I meant. Okay. And the limit as x approaches -1 from the left of f of x is equal to the limit as x approaches -1 of this one. And so we're going to say x minus 1 squared. Okay? So this is not... What's up?
Those are not. Those are, again, not helpful.
Well, we know that this must equal this. So I know that this has to equal this.
Yeah, because you input plus and minus. So those functions are therefore not going to work. They can't.
Well, they're
going
gonna
to
work.
that.
Well, look,
They're
we're
limited.
we just say
Because they're
ax
not-
minus 1 equals x minus 1 squared.
What I'm saying is that what you said there is x approaches -1.
Uh-huh.
Limit x -1 of ax minus 1.
Yeah. What's wrong with that?
That means at -2 it works.
What? What?
I'm doing a state. I'm doing what you.
Yeah, so watch.
Work.
We're gonna we'll solve.
I'm
we'll solve
doing is
this.
making plus and minuses on there.
Oh. One sec. You just plug in -1 is all you do.
I'm making you put pluses and minuses on the limits.
Oh no, I don't want to put plus and minuses on the limits here right now. Oh, you want me to do this? Really? Oh, okay.
That's
All right.
Motherfucker.
Okay. All right. This is the nitpicky stuff that people get fucking pissed off at math though. Like whatever. It doesn't change anything. Basically, what happens here, dog, is you want this to equal this when x equals this. That's how this works. So, in this case, it's a times -1 minus 1 needs to equal -1 minus 1 squared. All I did is I substituted in my boundary point here, which was -1. Did that make sense, Sebastian, to you? Yeah, okay. All right. So, this is -a minus 1 is equal to -2 squared. So then I have -a minus 1 is equal to 4. So then -a... No, we're getting a value for a. So watch. So then -a is equal to 5. So a equals -5. Do you see how we did this? So in order for the limit to exist as x approaches -1, I need the value of this function at -1 to equal the value of this function also at -1. Because as x approaches -1 from the left, that means it's approaching from x is less than -1. And then as x is approaching from the right, that means it's greater than -1. So, yeah. How I would like to graph this here, I can show this to you if you want. Let's pull up Desmos, right? Desmos will be able to do this. Where's my graphing calculator? Okay, there we go. So we had x minus 1.
You can leave the
Why is
a.
Yeah, and I think we can add a slider to it, Seth. I'm pretty sure we can, right?
Yep.
Yeah, this is cool. So watch, this is x minus 1 squared. And then this is going to be ax minus 1. Oh, yeah, then I need to add a slider for that. And then ax minus 1. Very good. Okay. So what this is here, right, is this is the graph. So the red graph is x minus 1 squared. And then the blue graph is ax minus 1. And then as we move this, that'll change what the value of a is. Okay. And what I need to happen is like, and let's do this. Let's say x is equal to -1. Let's do that, right? Is that at this point here, when x equals -1, I need the red graph and the blue graph to like meet each other, okay? And what we'll find, right, is that happens right here. So when a is equal to -5, okay? Can I make these thicker, dude? These are so thin, bro. What?
You can.
How do I make them thicker? I need some thick boys.
Well, you're not using Desmos on
Yeah.
your.
Yeah.
It's not-
Damn. I wish I could make it thicker. Cause this, I don't know. This is like really thin to see.
You can click on the point though, so.
Yeah. Okay. I swear there's a way to make these thicker. hit the wrench. Oh, he said hit the wrench. Wait, where's the wrench? Ooh,
Top
wrench. There we go. No. Oh, I can cut off the domains at -1 and settings equals thick mode. I do need that, bro. Okay, wait, let's make it like from -2 to 0. Projector mode. Ooh. Ooh, that's cool. Okay, there we go. Mine actually has a thick mode. Okay. All right, so this is what I wanted to show. Okay, so first of all, this right here, right? This is the graph x minus 1 squared, which we know from the question, right? That was defined when x was less than or equal to -1. So that means for everything to the left of here, right, to the left of the purple, that's what the red graph would have been. And then ax minus 1 is the blue graph, which is everything to the right of -1. And I need these two functions to meet each other at x equals -1, because that's how the limit exists. Because that means as I come here from the left, I approach the same value of y as I come from the right. And so, yeah, if you move this, you see as we move this, right? We just needed to hit like that. That's pretty cool. Desmos is pretty dope, yeah.
Make it a little bit nicer, a little bit more easier to show.
Yeah.
Go back to your Desmos graph.
Okay, let me pull it up. And then Sebastian, we'll do your next one. Just give me a second.
For red, wait.
Oh, I see. Are you saying Endar saying I could make it piecewise, right?
That's what I'm about to do. Yeah.
Yeah,
Gonna piece.
How do I do this? Oh, he says
You'll hit curly bracket. Curly bracket.
like that? Oh no. Ooh.
Curly bracket.
Curly bracket. Okay. Yes.
At that. Delete. You have to rewrite the function now.
Okay, whatever. Is this work? No. Okay.
No.
Curly bracket.
No, not
X.
first. Take the function. Take the function first, but yeah.
Oh, take the function first. Oh, okay. So you do x minus 1.
Oh.
Okay, I see it. Learning how to
Do all
code
this-
Desmos.
Take all your functions again.
And then oh no. And then curly bracket. And then you say
we know greater than or less than.
there we go.
Then-
Cool. Okay, cool.
And the other
Very
one,
cool. Very cool. And then the other one was ax, add a slider for x.
A.
Minus 1. Cool. And then that was for
Curly bracket.
curly bracket x. That's really cool, Seth. Thanks for showing me that, dude.
And the other one, x equals -1.
And then yeah, we can add another graph.
You want your
Right. Okay, so watch. Yeah. Oh, look at that. That's so dope. Look at that. So as you move it, you can be like, ooh, where does it? I need it to meet right there.
We'll never cross that green line now. It doesn't
And then
meet
here,
there.
let's turn on projector mode again.
It doesn't meet. It doesn't meet yet.
Yeah, at 5 it does. Yeah. Right.
And at 5.1 it doesn't.
Yeah, exactly. So this is cool. So this is what this is what the ax minus 1 looks like for different values of a. And then the purple is what x minus 1 squared looks like. And then you see that in order for them to meet right there at x equals -1, we needed a to equal to 5, -5.
It's supposed to be -5.
That's so cool. That's dope.
That's dope.
Desmos is, they get it on the SAT and shit, dude. They get to use this. They get to use Desmos on the SAT. Like what?
For varying complexities, but
Dude, all my exams would be on easy mode, bro, if I knew how to use if I had Desmos.
let's be more careful this time.
Okay.
Find the A&M so that G
Ooh,
of X
okay.
are number
So yeah,
one.
here's the weird thing here, Sebastian. So you need the domain here. Oh, he brings up a good point though. So Sebastian says, I'm confused because -2 is not part of the domain. I mean, you're not wrong. I think your teacher might have fucked up here.
So it's natural additive 1. I don't know that.
Right? You technically
Teach me
can't do this. This is not defined.
Yeah.
Is it? Am I allowed to take the e to the ln first and then just like get rid of it?
No, you're not.
No. Okay.
The ln of something other than ats. Imaginary numbers, of course, but we don't like imaginary numbers.
Yeah. So
yet.
okay. This is gonna be the argument between like the math gods and like a high school math teacher. Technically, this is not defined. Technically, you cannot do this. But what you learn in high school math is that e to the ln of x is just equal to x.
At any point, ats. Yeah.
Yeah.
But
So.
Right at the moment, we're doing based on the rule. that
Well,
the
this question is impossible if we don't assume these cancel, right?
We cannot assume they cancel because the student does not. Because students in that grade. I don't suppose that student is in high school. The
Students in high school, so I think we have to assume it cancels. I don't think there's any way. There's no other way to do it, right? I don't think it's solvable if we enforce that this can't be less than 0.
It's natural one of the function. It's bit.
Yeah. Okay, so I mean it's kind of lame, but here we go. So kx squared minus m is equal to, let's say, 2x plus 3, and then this is at x equals -2. At e to the ln of x is defined in the real numbers from 0 to infinity. I agree. Well, okay, so here's my question, Sebastian. Are you allowed to be like a smartass in your class and tell them that this is wrong? or do you just want to like get what the answer is, like assuming that your teacher like kind of messed up?
It's not,
yeah, right. That is peculiar. It is peculiar, Saint. Why they didn't just write 2x plus 3? They're trying to be too clever. I agree. Yeah, everyone in the chat here is like, yeah, your teacher's trying to be too clever, and they're actually messing up. Okay. So whatever. Let's assume this goes away. So this has to equal this at -2, and then kx minus m has to equal, or here, I'll write it the other way around. Sorry. And then 2x plus 3 has to equal kx minus m at x equals 3.
Yep.
Right?
Yep.
So that is, that's like the limit exists. But then I think for continuity, we need to prove that the derivatives also match, right?
No, the point of f of -2 is the same in both cases.
Oh, okay. Okay, so this is the limit exists. And then also... Oh.
Yeah.
Oh, well, this is the same thing we said.
Derivative matching would be C.
Yeah, okay. So we got to solve for k and m. Oh, and we can do this, right? Because we got 2 equations and 2 unknowns.
But we're not there yet. We have to plug things in for ats. We would have this.
Yeah, we're gonna do it. We're gonna do it. So we have k times -2 squared minus m equals 2 times -2. That's it? Okay, cool. Thanks, Smith. Yeah. I always forget. So I think for it to be differentiable, I think the derivatives have to match, right? That's the other boundary condition you have to get.
We're not dealing with that today. So
you can say your calculator yelled at you when you tried to plug an e to the ln bit. Yeah. You could.
Yeah, otherwise we'd have to say this is impossible.
Yeah, otherwise this is impossible. What's up, Bernadine? What's up, my guy?
Not quite right.
How did I fuck up? Well, I need the minus m, right? That's it, right?
Yeah, you need it, or otherwise this is completely done with. We don't even.
Yeah.
We need that m where there's.
Nice.
Mathematica doesn't complain? Okay. Okay, Jeff, if Mathematica doesn't complain. Oh, thanks for the follow. John Brongus. Yeah, okay.
Do it and simplify this.
Yeah, now let's just simplify this. So what is that? That gets me
arrow. We can just arrow it over one row.
4k minus m is equal to -4 plus 3, which is -1, right? And then oh, okay. So then 9 is equal to 3k minus m?
Yep.
Okay.
Oh, they're so nice. They're almost so, they're so close.
Wow, look at Bernadine. Bernadine says they got a 5 on AP Physics 1 because of me. Oh, thank you, Bernadine. That's dope.
That's dope.
Appreciate that,
Okay.
man.
Wait,
It is inequalities. Okay, so let's just solve this.
before we
so-
continue, E to 2 I pi has a point.
So I'm being pedantic, but there aren't any absolute values in the function, so x is less than 1.5. Is it? Yes, Zach. Yeah, we were
Yes,
talking about that earlier. We said that the teacher here tried to get fancy, and they fucked up.
Is
Yes,
that
so
we cannot-
Wait. So he says discontinuity. Sorry. You mean continuity is arguably impossible, right? Yes, thank you. Okay, yeah, cool. Yeah. Okay, so
So-
4k minus m equals -1. 3k minus m is equal to 9. I'm gonna just subtract these two functions from each other. And that's just gonna, oh, this is so nice, because now this just gets me k is equal to -10, right? And if k equals -10, then or whatever, plug it into here, right? So you get -40 minus m equals -1. So then you get m is equal to -39. Yeah, you can send me any question.
My man.
Yeah, if you want to do it, just go to the actualdiscord.com/submit, put in your username here, put in a screenshot of your picture, and we'll go through it. Wolfram Alpha doesn't complain, really? E to the log of 0 is 0? Don't think so, bro. What? Dude, that's hilarious. Dude, why? Is Wolfram Alpha a lie, dude? Zach, what's going on here?
Because it's power of complements.
Okay, so sorry. He said, don't we have to check
take
this
your-
for x is greater than 3? So, yes, we did do it,
Wait.
right? So, when we did this one here, Sebas, this right here was checking at the boundary of x is equal to 3 between this function and this function. And then this one right here was checking at the boundary at x equals -2 for this one and this one. Right? So if I call this like 1, 2, or let's call this like A, B, C. This was checking between A and B, and then this was checking between B and C. Yeah.
So what's your answer then?
Oh, sorry. My answer is k equals -10, m equals -39.
If there's an if statement here.
Okay.
If what?
If my teacher's not a dumbass, or what? Or if e to the ln of x is equal to x, which it's not. It's not.
Yeah, that's the if. Which,
Yeah. Wolfram Alpha knows about complex numbers. Oh, okay. That's how it's doing this. That's cool.
But we're not working with complex numbers. I don't
We're
think,
not
in
working
this
with
case.
complex numbers.
Oh
We never
no.
say-
You done messed up, Aaron.
Yeah.
Therefore, we need a statement.
Cool. Okay, nice. Good question there, Sebas. Very good. Sensation, I think you should, dude. That's a pretty sick. What is this? Sensation's asking, should I do this? I think this is pretty cool, Sensation. I think you do need to get this, bro. What? There's
No,
a Mortal Kombat machine for 500 pounds, dude. That's pretty cool.
I've
Anyways.
double checked it. It's a full-sized arcade machine as well.
I feel like you could build one of these things easier, though, Sensation. I feel like you could build it easier, right? Can you do differential equations? Yeah, I can. Well, it's just like it's just a screen, right? It's just. I mean, the cabinet's probably pretty nice. That cabinet's pretty cool. But it's just.
I would wager that the board is probably worth more than 500 quid realistically.
Oh, you think the joysticks and the buttons here are worth a lot?
No. The PCB.
Oh.
I spent a lot of time in Tokyo looking at PCBs, and they were stupid money.
So I've seen these, and I feel like they run them off like Arduinos now. Like they don't even run the OG boards off them. They run some sort of Arduino with Linux, and it's an emulator.
More than likely. As I mentioned, it's a full-size cabinet.
Yeah, that's pretty cool. I mean, dude, the shipping alone would be very expensive, right? I mean, this is massive. I had that. I was at an Airbnb last weekend for like a friend's birthday, and they had golden tea. They had an arcade version of golden tea.
Next up
cool.
is tension.
Yes, let's do.
Problem.
Yes, let's do the tension problem. Very good. Thank you, Zach. Okay,
Yes,
let's do.
We have 2 questions first, though. You have any students on the list today? It is 10 o'clock.
I don't think we're missing anyone so far.
No, I mean like students on your help after stream list.
Oh,
You have to go help
I do have to go. Yeah, probably in the next like 10-20 minutes, but I can do a couple of
Okay,
these.
so it is time. So
I appreciate you looking out for me there. Thank you, King Boss.
Oh,
Yes, King Boss.
King Boss is the first problem.
I see
That's
this
problem,
question. Let me do this, and then we'll do Zach's.
We might have a differential equation too coming in.
Okay, find the optimum
Okay.
integer solution to the following LPP.
Oh, great.
What the fuck is this?
This is an optimization. This is
Oh,
simple.
this makes me sad,
This
dude.
is an optimization.
This makes me sad.
This is an optimization problem. Is what this is.
Okay, Zach
So
says
we're-
it's linear programming. Okay, all right.
Oh,
Is this
that's-
DiffyQ?
okay,
I don't
Matt-
feel like this is DiffyQ. Well, let's try it. Okay,
Let's see.
Z.
So-
Z is equal to x1.
But that's 2. So x plus y.
Okay, so yeah, let's call it x plus y.
This is gonna be optimization, so it's gonna be a neat one.
And then 3x plus 2y is less than or equal to 5, and then y is also less than or equal to 2.
Golf. Oh, and x and y are greater than or equal to 0.
Yeah, and x and y are greater than or equal to 0, and they're integers.
Alright. But before you continue, read your y is less than or equal to 2 state. What do you know?
Sorry, what?
Y is less than or equal to 2, so therefore what?
Oh, y can only be 0 or 1. Or, yeah.
Or 2.
Sorry, what?
Y is
Oh.
less than equal to 2.
0 or 1 or 2. Okay, cool.
Or so there's
So
y's values.
I have a bunch of people in the chat coming up with a bunch of different answers here. So I see the Diophantine equation. I see just draw a sketch.
Easily.
Um, Sure. I think a sketch wouldn't be bad. And then,
what?
sorry, I'm trying to maximize x plus y, and then I think an exhaustive search is literally the easiest. Yeah, because we only have 3 options, right?
Well, one value we have, but we don't know what x is. X can be any number we want as long as it fulfills this setting equation.
Yeah, but no, as long as it's less than or equal to 5. But there's only okay. So let's say like case y equals 0, right? If y equals 0, right, then this goes away. And you have 3x is less than or equal to 5.
But
So right, so that puts restrictions on x. X can only be 0 or 1.
yeah,
Right?
it can be 2. So
Yeah. So the case y equals 0, you have x equals 0 or 1. Okay.
So z is what?
Okay, so z is equal to 0 or 1. Okay.
0 plus 0 is 0 plus 1. Case
Yeah.
2, y is 1.
If y is 1, then 3x
is that?
plus 2 is greater than or equal to 5. So
So x
3x is
is-
less than or equal to 5.
Oh, repeat.
So
it.
x is equal to 0
0
or
or
1.
So what?
So then you have 0 is equal to 0 or 2.
Now let me eliminate. Let me do elimination. Case okay. Can't be 0, can't be 1, can't be 0.
Yeah.
If you go on your top row on your z's, it can't be 0, can't be in 1 because it has to be maximum. Can't be 1, can't be 1. So
Uh-huh.
it's 2.
So then we have 3x is less than or equal to 5. So here x can only be equal
no.
to
No,
0 or 1.
No.
Wait. No, 3x is less than or
Yeah,
equal to 1.
probably.
My bad. I
Yeah.
fucked up.
What?
So x is just equal to 0.
So therefore what?
So z is equal to 2. So the largest sum is 2. So yeah,
And that's what
Zach has some your solutions, right? Yeah. You have 0 0 0 1 1 0 1 1 and then 2 0 or 0 2, sorry, however you're doing it. And then the largest sum is 2. Okay. That's a pretty cool question. I like that. That's pretty fun.
M capital M
Nice. Yeah, so Z is equal to 2.
No. Maximum Z.
Well, the max of Z.
Max.
You could do this graphically as well. You could.
There are
Yeah,
one
you-
or two, but maximum wise.
You totally could. In Desmos, I could say like, well, I would need to do this in 3 dimensions then, wouldn't I?
Not all, not necessarily.
My video will only take you 3 hours to understand. Okay, cool. That's a good question. I hope that helped you out. Here, let me do. I want to do Zach's while we have time.
Yep. Yeah.
So
Let's see if
let me
there's
let me,
anything
let me
else.
make sure there are answers to this. Are there answers to this one?
Yes. There should odd numbers are answer keys.
Where are the answer keys for it?
Is in a different section and normally odd number answer keys.
I just want to make
That's
sure that
normally
that we have it somewhere.
It's normally odd number answer keys.
Bro, look at these
normally.
questions, dude. What? Like what? The burning fire, dude. What?
That's it would be under the answer keys for
Oh, I don't think it is. It's only in the problem section. If you click this, then it shows you the answers.
yeah.
That's
so you have to
okay.
look at the problems in the
I
list the
believe in
problems-
my physics
at the
abilities to solve this without an answer key.
Go to the problem section. You don't need the answer. Go to problem section and see if
Yeah.
any of those are tension problems before we do anything else. If
Well,
there's
they're
any
all
other
yeah.
tension, we take
Yeah, there's a
problems
bunch of other tension problems.
that
Yeah.
have an answer to them that has a tight answer.
Yeah, I
to
mean
it.
this one does. This one has one. This
Okay?
one has
That's
one.
not tension. That one's okay.
It's
Just
okay.
take a tension
I'll do the one Zach asked because I believe myself. Also because like I'm literally this is literally my class I teach at UCLA. If I can't do this, I gotta hand in my degree, dude. I'm be like, no, I'm sorry, can't do it. Done.
If the lead
What?
is suspended by a fraction set up as shown in figure 4.29, what is the tension in the?
Wow, fascinating.
That's it. We're not
Okay.
given anything.
Okay, this is actually
Remember.
really interesting.
You know, tension setup. Find the tension.
Okay, this is kind of a nightmare of a question, but it's okay. It's doable. So, what I'm gonna do is I'm gonna consider the leg.
Make sure it's here.
Yeah, I'm gonna consider the leg as
Yep.
a This is a hilarious question, Zach, by the way. I'm gonna consider the leg to be just a block, okay? And we're gonna look at all the forces on this block, okay? So
A torque, there's no such thing as air resistance, etc.
yeah, okay. So I'm gonna have I'm gonna have tension here.
Well, tension
And
and
Oh,
It's
interesting.
pulley.
Oh, it's all the same pulley. Holy shit. Oh, okay. That's
tension
cool.
and set.
This is all the same piece of rope.
Yep.
Yeah, so this is the cool thing about ropes in
Okay.
physics. So, let the leg be a block. Spoken like a true physicist.
Good job.
Yeah, imagine a spherical cow. Okay, so here's the cool thing. So, with ropes, the tension in the rope is constant. So, if it's connected here, that is going to exert a force T upwards. And then this part of the pulley here, Zach, I'm just gonna like try to I'm just gonna like move it to the center of this because it acts the same way. So then what I have is I have a tension here, and I also have a tension here.
Some angle theta. At some angle theta.
At some angle theta.
So
This is
There's
really
also
cool. This is
another
this is why like this is why pulleys do cool shit though.
there's
Okay.
also another block being pulled down.
We're gonna get to that. And then there's also the weight of the leg. Okay.
And the block pulling down.
We're mathematicians, not doctors. This is physics. Yeah, this is mechanics. Okay. So the key thing here is that if the leg is not moving, and I'm only looking at the forces on the leg. I'm not worrying about this right now. Not worrying about it. Okay.
What's important though to the loop because it's it's
Um,
pulling on. Therefore, it's important. It's all the same rope, so therefore that as that block being pulled by MD there is pulling, it's pulling the lead.
You know, there's actually kind of a bug in this one though, right? Because technically there needs to be a force pulling it this way as well. Right? Yeah, these aren't all the forces. Because there is a leftward force. Yeah. So technically there's this. There's the force of the knee. We can assume spherical livestock, but to assume the leg is rigid, we need to see the bone. The force pulling it that way is the guy trying to hold on to his leg. Okay, all right, okay. Okay, there's also the force of the leg here. Okay, all right. I think we only need to worry about the y. We only need to worry about the y direction. Watch it. So all we have to do. So for physics here, we say that the sum of the forces in the x direction is equal to the sum of the forces in the y direction, which is equal to 0. Or really how you write it is this. Sum of forces is equal to max. Sum of the force in the y direction is equal to may. And if this thing is in equilibrium, or it's static, it's not moving, then accelerations are 0. So I say this is equal to 0, this is equal to 0.
So we do need to deal with the blot that's pulling as well.
We will get to that. So I'm going to look at just the forces in the y direction real quick. So I have these forces pulling up. So I have t, and then I have plus t sine theta, right? Because that's the component of t here. It's like ty, okay? But then I have minus t sine theta.
Elimination. Well,
and then it will eliminate, and then we have minus w leg.
Let me answer this question. Are theta is theta and theta the same angle?
I assume if they wrote it as theta, it's got to be the same angle, right?
You made an assumption there, so do we can say so?
Yes. Okay. W leg. Yeah. Okay. All right. Cool. So whatever. This goes away. And so you get that tension is equal to W leg from that, right? Okay. What was the question even asking?
Y direction is.
Okay.
But
So,
W is mg.
so bro, that's just it, right? I mean, the other thing you can look at from this point of view, okay? If you look at the force diagram on this has tension pulling this way, and it has mg pulling this way. And these sum of forces has to also be equal to 0. So you say that t minus mg equals 0.
Yeah.
F of leg is taken by the rolls.
Wouldn't the component will be t cosine theta? Says someone.
Well, okay, t cosine theta and t cosine theta here would have to add up to this in the x direction.
It is what they're trying to tell you. If they're trying to see. Like,
that's it. Pulleys are such simple machines. Well, I mean, here's the cool thing. This tells me that t is equal to mg. So mg equals w leg. Okay, cool. So the weight of your leg has to be suspended by basically the weight of, like, the block. Yeah. So the tension is just equal to mg. So tension is equal to mg. Which we don't know. We don't know what the fucking mass is here, but it's also equal to the weight of the leg. This seems like a really elaborate thing, all for nothing. Because usually you'd at least get, like, some mechanical advantage out of this, right? There's no mechanical advantage here.
What's the picture caption?
It says, a leg is suspended by a traction system, which wires are used to transmit forces. I mean, cool. It's basically showing you that
change the direction of
that all the pulley's doing here is changing the direction of the force from something pulling down here to something pulling up here. This is all just a fucking red herring. It actually doesn't. There's no mechanical advantage from this. If you wanted mechanical advantage, which would be cool, you would need to do something like this. Like you have to have it like doubling on itself. Let me do like a classic. Well, let's see if actually they have one in there. This is why OpenStax is fucking garbage sometimes. I'm not sure mg can equal w leg because the knee can hold some of the vertical weight as well.
That's right. There's that knee. There's an extra x value.
Yeah. But now we're talking about this as well. I mean, I could also get into like the torques on it if I really wanted to, but I don't think this question is as hard as it's supposed to be. Let me see something that's like actually cool with like pulleys.
But that one, there was down there on the wall. Further down, there's the wall image.
Yeah,
Yes.
that's a cool one.
There's an answer key with it. So you can
What's up, Cumancy? You mean you shouldn't hold your leg at a 0-degree angle when it's in a leg brace? I'm not a doctor of medicine. I'm just a doctor of physics. Don't rest. Yeah, no rest for the wicked. Yeah, that's a terrible question. Let me see if there's something with like pulleys in here. Because I want to show you like why like pulleys are actually cool.
pulled. You get pull and pulled.
Yeah, but where's pulley?
You asked for pull.
No, ask for pulley.
I said pull.
I definitely asked for.
Original pulleys change. Yep. No.
Is this similar to AP
Pull?
Physics C mechanics? Yeah, I mean it's definitely involved. Yeah.
How about pull?
Why is it
How
still giving me pulled?
Yeah, that's what you asked for. Contains the word pulley.
I did change it to pulley, dude. Bro, what? I'm looking for pulley.
Contains the word. Contains the letters pulley. Pull. Pull contains the letters. You got it.
Why simple machines
we're
don't?
talking-
Oh, this is cool.
There.
Why do simple machines not violate the conservation of energy? Because you can have a force advantage, but then you have a distance disadvantage. So
9.24. Image 9.24 has one instead.
image 9.24. Sorry, where was that?
No, it's on the list. No idea.
Okay, this is getting weird.
Saw it on the lists. Image 9.
I mean, this is cool. Yeah. Yeah, same work, but less force over longer distance. Exactly. That's how a pulley works. So
Get one.
pulleys work.
Yep.
The reason why like pulleys work for mechanical advantage is you apply a lower force over more distance, and that creates a larger force over a shorter distance.
Searchy.
Oh, here we go. Oh, I found it. This is cool. Yeah, look at all these like weird ass fucking pulleys.
You're gonna use that one then?
I'm just gonna like kind of
Pulley,
show
but
them,
that's not a-
kind of show them how it works.
I have found a list though. You need more.
What about inclined planes or the wheel?
Nice
Yeah.
traits.
Kenny C, we're just messing around learning some physics. So this is cool. This is cool here. All right. So, say for instance you have a pulley, right? That's connected here. Okay? It's fixed. It's fixed on this pulley. It comes through and then it comes around, right? And it comes this way. So, what we know is that for rope, the tension in the rope is always the same. So the tension in the rope here is the same as the tension in the rope here, which is the same as the tension in the rope here. But if you look at the force diagram, right, on this pulley, you have weight pulling down and two tensions pulling up. So this is why tension is equal to half the weight, right? So you only need to apply half the force to be able to like hold this thing still. And then bro, now, dude, this is a mess. Look at this, dude. What? So this is like some like pulley from hell situation, but I guess you could have this coming around this, and it needs more T's. Yeah, dude, just more T's. But this is a case where now you have 4 tensions that are helping you pull up the thing. But yes, to Jeff's question, right, by conservation of energy, right, what happens is because you do, so work, which is equal to like change in kinetic energy or whatever, change in energy, is equal to force times distance. If you have like less force being applied, then you need more distance for that force to be applied. So that's why you have to pull this rope twice as far for this to go up like 1 unit. If you want this whole thing to go up 1 meter, you have to pull this 2 meters. Okay? And then in this case, since it's a factor of 4, you would have to pull this thing 4 times as far for this thing to only move once. Yeah, it's because of this, Zach. Because work, which is energy, has to be conserved. So force times distance. So that's the trade-off. You end up trading off distance for force. You looked at the solution to Zach's question, but it doesn't make any sense. Where's the solution, Fembox? Can I see it? Hi, I am a finance student to teach from like basic. Yeah.
I do have one.
Ooh, I do have to run. I do gotta run. Sorry, my friends hit me up now. Okay. Yes. At some point I have to ask why work isn't a force over time. Work is force times time. Yeah.
I found this, but
oh yeah, that's another cool one. Yeah, I had it on the screen before. Did I have the solution on the screen before? Did I? Work was force times distance. Oh, sorry. You're thinking power. Sorry. Power is equal to work divided by time, which is force over time times distance, which is the same thing as force times velocity. Yeah. Distance over time. Yeah. Okay. Cool. All right. I think that's good for today. Anyways, let's end the stream out. All right, thanks everyone for coming to Actual Education Office Hours today. I had a lot of fun working with you guys. If you just found us today on the stream, or you just found us in the last 5 minutes, welcome. We've been streaming for almost 2.5 hours now. Work is energy. It is. But we do stream 3 times a week, and we're a nonprofit where we help you guys out with math and science questions. So please come on by. If you want to know when we stream, there's a calendar.
And let's see, you weren't even in the. I don't know if you were in the math corridor today or not.
Here, let me post the calendar for people. So here's the calendar. So this is when we stream, and when also all our awesome friends stream. So Zach, if you want to ask math questions tomorrow morning, Zach right here, E2iPi, he's going to be streaming at 9:30 Pacific time tomorrow morning. So in about, what's that, 14 hours? In 14 hours, you can go over to Zach's stream and ask him more math questions. Oh, nice. You understand why MA is so important for distance. Yeah, great. No, I'm glad. Yes, exactly, King Boss. 4 meters is 1 meter. Yeah. I do complex math engineering questions. Yes, everything. Or at least I'll attempt it. So please feel free to come on by. If you want to get notifications for when we stream, make sure you hit that subscribe button on whatever platform you're on. If you're seeing us on TikTok, if you're seeing us on Twitch, if you're seeing us on YouTube, hit that button, turn on notifications, and you'll get notified next time we stream. Because our next official stream will be Monday. I'm debating adding some weekend ones. I might try some weekend streams just because we're getting towards the end of the year, and I know a lot of people have final exams and need help. So I'm debating adding a weekend time. If I do, and you're subscribed, you'll get a notification when we go on. Yes. Yes, there is always a link to submit questions if you want to get help. The link it's there at the bottom there, actualdiscord.com/submit. You can go submit it there. All my times are Pacific. All my times are Pacific time. But this is my personal calendar. But yes, okay. Also, if you go to that actualdiscord.com/submit, you'll also see links to join our Discord. If you join our Discord, that's also the best way. If you want to DM me things or like ask questions, or I can point you to any of the other awesome math people, streamers we have in our community, join our Discord, send me a DM, and I'll be happy to send you over to their Discords and their streams, and they can help you out. Cool. Okay, I gotta go. So let's go raid somebody. Who's on?
Don't know who's live on the math channel because there's not. That's no one on my side.
All right, let me see. Let's go to raid channel. One sec. Yeah, it was a fun stream. I learned a lot of stuff today. Let's see. Who are we following?
There'd be some math editor, don't there?
Moo Hoodles is on. Nerduino's on. Merryweather's doing stuff with the Raspberry. Let's go give some love to Moo because she just started. Okay, cool. Okay. Enjoy the rest of your week. Have a wonderful Memorial Day weekend. It's a 3-day weekend. Enjoy. We will see you guys on Monday. Peace.